How to label a triangle. This is important. This is really important. So a triangle, capital letters will tell you the angles, and lowercase letters are the sides, but they have to be placed specifically. That opposite from angle A is side little a. And opposite from big B is side little b. Opposite from C is C. Yeah? Did I teach you that? Oh, I'm good. Anyway,
I'm good.
but it makes sense. Think about it. That A corresponds to A. Because.
It's the angle. It's the width of the angle.
It goes like this.
Hey Liz, can you aim your face up here?
Can you angle your face this way?
Can you angle it?
Angle your face.
Turn to the side. Your eyeballs, can I see your eyeballs? Okay, so check it out. If A is big, then A is big. If angle A gets bigger, the side A gets bigger. If angle A gets smaller, side A gets smaller.
See?
Does that make sense? So if you got a big B, little b, little b.
Little B is my friend.
Yeah. And so this is kind of nifty if you have a triangle where, say, this is 9, 10, and 11. Your angles should correspond. That your smallest side should correspond to the smallest angle.
47.
So maybe this is 50 degrees.
Hey, close.
And then maybe this, the medium side is going to be a 60 degrees.
I'm going to tell you if you're messing
And this guy is 70 degrees. And I made this up, and this is probably totally wrong, but in general, your smallest angle should correspond to your smallest side. Your biggest angle should go to your biggest side. And if that's not the case, wrong.
You done messed up.
You done messed up.
Yeah.
You done messed with your daddy's penthouse.
You messed up, AA Ron. Right? So this is just like checking your right triangle. If the hypotenuse is not the longest side, you slipped in. Okay. So we got the labeling down. Okay. Law of sines. Okay. So remember, angle A corresponds to side A. Right, Liz? Right.
Sure.
So the law of sines is going to illustrate that beautifully. Check this out. The sine of angle A over side A is the same. That ratio is the same as the sine of angle B over side B. And that's the same as the sine of angle C over side C. It's beautiful. You all have it memorized already.
Yeah.
Yes.
Sine of A over A equals sine of B over B equals sine of C over C.
Yes.
It's, I love it. It's beautiful. And it's pretty versatile. Right? So if I don't know anything about angle A or side A, who cares? I got these two. I can use that.
Heck yeah.
If I don't have any information about B, I can set this equal to that and just use that. Or this. Right? It's so cool. It's easy to remember. It's versatile.
Can we do an example?
I have a question.
And we're going to do an example. Yes, question?
So if you don't know what little a is, could you do the sine of A over little b?
Well, so this is how you set it up. You plug in the stuff you know, and you solve for the thing you don't know. So generally, remember I said we need 3 pieces of information?
Yeah.
So if you erase one of these, you're not going to need all this. You'll find out what stuff you have, and you'll plug in 1, 2, 3 pieces of information and find the 4th one.
Cool. So you're never going to have them all sweet together?
Nah, well you don't need to. Because you'll have 3 pieces of info and 1 missing thing to find.
They all equally.
And yeah, and you throw it in the mix. Jasper?
That works for all triangles.
It works for the 2 cases that we just wrote about in our notes.
Right.
Where it's
The asa and the as and the ass.
yeah, angle side angle, and angle side, and angle side side.
What about if you have no knowledge of sine A or A, and you have all of the knowledge of sine B, sine C, and C? All the knowledge.
That's 4.
Then that'll be a law of cosines.
Okay.
So this only works for if you can set it up and plug in stuff and have one missing, then it works.
Okay.
And if you have that thing you just said, you got to use a different tool. Not be law of cosines. So
you can just find the angle by like subtracting from 180.
or that, yeah, that too. So here's an example. Let's say, what's that look like? Let's say, we'll say 40 degrees here, and then we'll say this is 10 centimeters, and then maybe we have, this is 50 degrees, and this is x right here. So the way that I remember the law of sines is that you have to have opposite stuff. So you see I have opposite stuff here, and then opposite stuff here with one unknown. So I'm going to do the sine of 40 over 10, because that's my opposite stuff,
And then the sine of 50 over x.
equals,
150 over x.
and then you just solve it. Bada boom, bada bing. Yeah, and so you can cross multiply and then divide by a thing, or a really neat trick is, if you want to know this, you can place your little finger on it, and then you multiply
That.
these and divide by the leftover thing.
Isn't that just cross multiplication, but
No, it's,
more faster?
yeah.
It's more faster.
Uh,
Yeah. But so, let me give you a calculator, if you're into that kind of thing.
Yep.
Who's feeling the calculator vibe right now? You into this?
What was that divided by?
11.92.
Yay, that's what I got.
Yeah. Yeah.
Somebody got 11.92.
No.
yeah.
11.92 centimeters. Now, does that make sense? Look at your angles,
Yes, it does.
right? Because this is a smaller side and a smaller angle. So bigger angle, bigger side. Check.
And it's going to be a 90-degree angle up there. It's the hypotenuse, so it makes
Equal
sense.
x.
Oh. Oh, cool. Yeah, I didn't do that on purpose, but yeah, it will be a 90. Okay, let's do an example where we only have one angle given. Right? Because what was this? What was going on here? Angle, angle, side.
Ah.
Okay. So let's do a let's do a something else. So should we do this here?
Yeah.
Okay. So so we have this angle is 50 degrees. This is 14 inches, and this here is, I don't know, 12 inches maybe? That's probably shorter than that. 10 inches. Okay, and then
Then what are we trying to find?
we're trying to find this angle here. We'll call it angle A. So again, I look for opposite things. And if I have opposite things, then I can work with the law of sines. So here's opposite stuff. Here's opposite stuff. Sine of 50 over 10. Didn't we do something just like that? And then I'm coming up with these great examples right off the top of the dome. Sine of A over 14. Okay.
So you would, okay.
So we want to solve for this guy. So
Diagonal,
we can do this thing, diagonal multiplication
divide.
Divided by 10.
But then you're
and leftover division.
So once you have to do an inverse sign.
Yeah, so you'll get that, and that'll be equal to the sine of A. So do it.
I got
1.07.
Wait, is it supposed to be inverse sign?
No, not yet. Just this times this, divide by that. Make sure you're in degree mode.
Yeah.
Anyone else get that?
I got that too.
Okay, and so now You do the inverse sign.
I got 10.7.
I got 2.7.
Oh, you divide.
You divide by 10.
I got
Yeah.
the main marker.
Oh, yeah, you did an inverse sign by accident, bruh.
Wait, so I just inverse
Well, yeah, when you do the
1.07?
inverse sign of
Oh.
1.07, it gets
It's
you.
That is a domain error. You can't take the inverse sign of something bigger than 1. So, what seems to be the problem, sir? I bet you
Is it because our triangle doesn't work?
this triangle isn't a real thing. Right? Because if this is 50 degrees and this is 14, 10 might actually be like that. 10 might be too husky.
Oh yeah.
Should we chop that down?
It should be like 7 or something.
4.
Or maybe, no, wait. Because we would need to divide by something bigger, actually,
To get it less than
to
1.
get it less than 1.
Yeah.
So actually, 10 isn't enough.
So 12.
So 10 is dangling, like Ruby's feet. 10 is just dangling. I love you, Ruby. Okay, so 10 needs to be bigger. So how about, should we make it a 12?
Yeah.
No, 11.
Okay.
That's a cool number.
Make it 12. So hopefully 12 will hit the ground.
Dang, that was.
0.89.
We got 0.89?
Yep.
Yep.
And then 63.34.
Anyone else get that?
I got 62.87.
Yeah.
I got 62.8.
Well, because I put the direct answer.
Oh, okay, I
Oh,
put
you didn't
sign.
round?
I put inverse sign of 89.
Yeah.
0.89.
Oh.
Yeah,
So,
I got
Dylan, what was the thing you got?
I got
87.
63.34.
I got 60.
And other people got 62 point.
87.
87.
So that's a good lesson that if we round this to 2 decimal places, it kind of makes a difference. But if my physics people, my sig fig people, this is a
It would
little
be
Yeah. let's go.
secret information to the extra nerdy. If we had 2 significant figures here,
We want 2 there.
this would be 63. This would be 63.
Yeah, so what matter?
Hey. So anyway, so if this is 63 degrees,
Oh, angle.
now does that make sense? This is the smaller one. This is the bigger one.
Yeah.
Yeah.
But that's not a right angle.
Correct.
It don't matter, girl.
Yeah, this would be acute angle.
Oh.